Hello, everyone. Thanks for joining the Security and Permissions Management webinar. We're recording this session and we'll submit a link to the recording over the next few days. Just a quick note, our next webinar, Jira Workflows Primer, is planned for August 7th at 11 a.m. Central. There are a few of us from Praecipio Consulting on today's webinar. Christopher Pepe, he'll be doing the presentation. He heads up our Atlassian practice and he's been working with the Atlassian product since 2004. I'm Christian Lane, founder of Praecipio Consulting, one of the partners here. Also on the webinar is Shayla Sander. Shayla helps coordinate these webinars amongst many other tasks and helps out with a lot of the business development activities that we do at Praecipio Consulting. So we're celebrating our 5th anniversary as Atlassian Expert Partners this month, and we became one of 4 U.S. expert partners in October of 2012. Over 98% of the work that we do is Atlassian related. We've got clients across the country ranging from small 20-person companies to Fortune 20 type companies across many industries, including technology, automotive, electric utilities, commercial arts, oil and gas, software development, gaming software, and just a whole lot. That's in large part due to the reach that Atlassian products have over the market. So we help our clients with process-centric technology solutions that facilitate traditional business process management, IT service management based on ITIL, and software development life cycles. In the SDLC space, we're helping a lot of our clients transition and transform, moving from waterfall to agile. But at the end of the day, whatever widgets you produce, we help improve the quality and throughput at the lowest cost. In the Atlassian space, we support our clients in all facets of Atlassian, whether it's implementations, solutions architecting, licensing, installs, upgrades, and maintenance, hosting and managed services, and training. We're pretty well focused in the Atlassian space and can help with anything Atlassian related. So with all that said, let's turn things over to Christopher Pepe. He's going to walk us through the webinar.
Good morning. We're going to talk about security and permissions management in the Atlassian suite. We're really going to focus on Jira this morning, but a lot of what we're going to be talking about, especially this first half of system security, is really applicable to all of the Atlassian tools. For the most part, they're a Java application that runs in Tomcat or some sort of app server, and you're going to kind of treat it the same way. I'm also going to focus on hosting in a Linux environment, but all the same ideas and techniques are applicable to Windows or any other environment. You just use slightly different tools. So we're going to go through system security, then we're going to look at specific security features within Jira, and then at the end we'll take any questions that you have. So whenever we talk about security, we're really talking about kind of a balance between usability and security. And in some cases, we kind of get security for free. It doesn't really add any real overhead. But in other cases, we really need to figure out, how do we get the most security for the environment that we happen to be in without making it too cumbersome for our users. And I think password complexity is a good example of that. We want people to have complex passwords so that we're not victims of brute force attacks or any of the other kind of rainbow tables, anything else that people would do to try to kind of guess simple passwords and gain access to a system. But if we make our passwords too complex and have too many rules and have too many different systems that have different passwords, then people tend to write them down and we have a physical security problem, or they save them to a file on their computer, and then we have just a different type of security problem. So really kind of finding that balance is part of the game in your enterprise. One of the major things that will determine some of our security features is whether we're on the public internet versus on an internal network. So if we're hosting in the cloud or if all of our services are public facing, all of our instances of Jira are out on the internet and you could access them just as well as I could. So we have to be careful. We have to be a little bit more careful with our security. Inside a corporate network, things tend to be a lot more lax. I would probably disagree with that stance in a lot of places, but a lot of people internally don't run over SSL, don't worry as much about passwords, and that kind of stuff. And there are still problems with that, but at the very least you have a largely known and largely trusted user base that has access to your internal network. So you can get away with a lot more. I think encryption is just kind of a no-brainer. It makes a lot of sense to do. It's not too difficult to set up. And computers being as fast and powerful as they are today, our internet connections being as fast as they are, the overhead of encrypting all of those packets and sending them over the wire really isn't that big of a deal anymore, and encryption really buys you a lot of protection, so it makes a lot of sense to do. At the actual server level itself, there are a number of kind of best practices that we can use to ensure that both the system is secure and that if anything ever happens, we can figure out what happened. So, named users and strong passwords, or even SSH keys are one approach to that. We've generally settled on somewhere in the 8+ character range, uppercase, lowercase, numbers, special characters. That's kind of the general formula for a good password, not based on dictionary words and all of those other things. SSH keys also can, if well implemented, can also give you a lot of extra security as well. One thing I don't like that we will see sometimes is, passwordless SSH keys at the root level. So once you sudo root, you can jump to any box that you want to. So I don't think that's a very great use of keys, but in general, keys can be a really good way to do it. Named users, I think, are important because if ever a account is compromised, it makes it a lot easier to figure out how did that attacker get in. Also, just having named users makes it a lot easier for you to audit. It's not necessarily a security thing, but we all have to deal with SAS 70 and those sort of things. So being able to audit who's doing what on a system is a really valuable thing to have. Plus, if we are using shared accounts, then we have to come up with some secure mechanism to be able to share those passwords as well. So that potentially adds another wrinkle to it. And then other things are just don't run as root. So when your named users log into this server to do whatever server maintenance they're doing, if they need to run something as root, sudo is the best way to approach that. You don't want to run any of your applications as root either. It gives the application too much power. If anyone were to compromise it, then they have a much easier time getting a root shell and taking over the system. But also just running as root, that means that the application's allowed to do anything that it wants to do. So if it has a bug or if it's somehow misbehaving, it's then got the ability to overwrite system files and other things that it shouldn't be doing. So in a lot of these cases, we always plan for the worst, and we have these, crazy movie storyline hacking attacks. But really, at the end of the day, it's going to be people fat finger something, they make a mistake, an application doesn't behave right, and that's really going to cause more of our problems than actual attacks. And good security is going to protect you against that as well, keeping everything isolated and letting it only do what it's supposed to be allowed to do. Along those same lines, you want to consider that when you're setting up your firewalls and your network routing and your network topology. In this case, we have a fairly standard setup where we have a Jira server, and users need to be able to get to it. Here we have an attacker listed, but that's also where your user would be coming from as well. So they're probably going to end up through some firewall, through some set of routers to get to the Jira server. You'll notice in this kind of crude network diagram, there's no route to the database server from where the user or attacker is coming in. You want to limit where people can get from any particular place. We've got on the kind of inside of the network, an SSH user can get into the Jira server and do things. But from neither of those angles can you get directly to the database server. Jira needs to talk to the database, but no user really needs to talk to the database unless you're trying to report off it or something. And in that case, then your best practice would be to replicate that database somewhere else and give people a read-only connection to it. That way they can report off it without affecting Jira. And then if they make any changes to it or thrash the database, it's not going to take down the application either. So as far as Jira is concerned, really the only ports you need open are 80 and 443. That's HTTP and HTTPS. 22 is SSH, so whether it's just from internal or from anywhere, you want to have some mechanism to be able to get onto the server, either physical access or remote access, so you can get in there and actually manage it. But as far as Jira is concerned, really 443 is the only one that you need open. We leave port 80 open as a courtesy to users. So if you go to jira.mycompany.com, that will hit port 80, which will automatically redirect you to SSL. And that's one of the things that we do, and you're probably doing in a lot of your applications, is forcing SSL. That way people have to use it. As far as outgoing ports, it's not as common to lock down outgoing ports. Usually the thought is that if you want to make an outbound connection, you can let it. With servers, it's usually a good idea to put at least some thought into locking down outgoing ports as well. So Jira is going to need access to an SMTP server. If you're using mail handlers, it'll need to be able to connect to a POP or IMAP server. And of course, it's going to need to connect to its database if they're not running on the same system. But other than that, you don't really need any outgoing ports open. You might need port 80 or 443 if you have third-party integrations. If you're connecting to Bitbucket for DVCS stuff, or if you're connecting to Salesforce with the Salesforce connector, you'll need routes open to those systems. If you want to take it even a step farther, you can only allow those outbound connections to specific servers as well, and that would lock that down even tighter. Once we put all the thought into how our server is laid out, how our network topology is laid out, we have everything really solid and really locked down. Then really the next step is monitoring, keeping an eye on everything, making sure that things are actually behaving the way that we expect them to. And the number one way that we're going to do that is with intrusion detection and monitoring. So again, monitoring isn't something that's necessarily there from a security standpoint. It's also there just to identify problems in the system. So if we're going to run out of memory or run out of disk space, all of those sort of things are things that we would want to know about. Looking for the patterns in the alerts that we get from our intrusion detection systems and monitoring systems, that can help us identify when an attack comes in or what type of attack is happening. But it's also just going to let us know that things are changing on the system. If you have a number of different sysadmins that are all adminning a box, a best practice to that is to have usually a change process in place so that changes are approved before they're made. But if you're not doing that, at the very least, a page in Confluence or whatever you use for a wiki to document all the changes that are happening. When we get alerts and we'll see something happen, we have to go around and ask everybody, okay, did you change something? Did you change something? Did you change something? Now that we monitor, now that we log all of that stuff in Confluence, all I have to do is just go to that server's page in Confluence and look and say, okay, yep, Isaac installed this new package, and that's what caused the IDS to send me an alert or monitoring to tell me something happened. I started off talking about SSL, how it's kind of a freebie and you really should do it, and I definitely think that's true. Even when you're inside your own corporate network, I still think run the application over SSL makes a lot of sense. If you're not doing that, usernames, passwords, as well as all the data in the tickets themselves is going over the wire in clear text. And even though your users are known and trusted, still sending usernames and passwords in clear text is never really a good idea if you can avoid it. So when you go to set up SSL in Jira or any of the other applications, you have a couple of considerations to make. So one of the standard approaches to setting up an Atlassian application is to use the installer to install Jira or whatever it is, and that's going to set up Tomcat and set up Jira to run within Tomcat, and then put Apache in front of it to act as a proxy. Usually those two are on the same server, so they can talk to each other in clear text, because there's no real way. I mean, there is. You could get on the loopback interface if you could get on the server and intercept it or whatever, but there's not really a practical way to intercept the traffic between Apache and Tomcat when they're running on the same server. So a typical approach would be to terminate SSL in Apache, and that is to have your SSL certificates installed in Apache, and it's serving everything over SSL, and it talks to Tomcat in clear text. You could take SSL all the way back to Tomcat if you wanted to as well, and you might do that if you are either directly hosting out of Tomcat or if your proxy was on a different server on a different part of the network. That way you could have encrypted traffic all the way back to Jira itself. You can also use SSL to connect to your database so that your database connections are also encrypted. If you're authenticating off of Active Directory or OpenLDAP or any of those other tools, you can encrypt that connection as well. That way all of your communication at kind of every level of the system will be encrypted, and no one sitting in the middle in the network will be able to intercept that traffic and get anything useful out of it. One of the main considerations you have to make then when you are setting up SSL is how your application links are going to work. Atlassian applications are kind of like potato chips. You can't really have just one. So once you get Jira and Greenhopper, and then you'll have Bamboo and Stash and Confluence, and you want all these things to talk to each other. To really get the most out of the suite, you want to use all of those nice deep integrations. So what you do generally is you create application links, and that will do most of the connecting for you. Well, if you're using self-signed certificates, or depending on who you bought your SSL certificate from, the different applications may not trust that certificate. So then you have to start messing around with KeyTool and importing those certificates into your key stores. That way Jira and Confluence will trust each other, and you can share data back and forth. So luckily, Atlassian has you covered here that at least for Jira and Confluence, there is a plugin which you just pointed at a URL. It'll go out, get the SSL certificate, and then stuff it into your key store for you. There's one more step where you have to copy the file over, but it tells you exactly what to do. For the other applications, you still have to do it manually, or if you're using a wildcard certificate, you can just build one key store and then use that key store for all the different applications. So, I know SSL is kind of tough. It took me a long time to get my head wrapped around it when I started doing security stuff, and when I first started out as a sysadmin. It was definitely kind of a black box I just chipped away at. I hated having certificates that expired, because then I had to figure out what to do with them all over again. So along the way, I learned just to document everything that I did. That way, at least I knew what I did, and I could reproduce those steps. And after a while, it started making sense to me, and I understood what was going on. The biggest thing, whether you intimately understand trust chains and know everything there is to know about SSL, or you know absolutely nothing about it, the really important takeaway is that it's worth doing it right. It's what ensures that the different systems that you're talking to are who they say they are, that the communication between them is protected, and that no one sitting in the middle would be able to intercept that and steal that data. If you are hosting out in the cloud somewhere and your system is publicly accessible to anybody in the world, you really need to be using SSL. You really shouldn't be hosting anything without it. If for no other reason than usernames and passwords are going over the public internet in clear text, but also all of your other information. If you wouldn't share the information that's in Jira with just anybody you met on the street, then you shouldn't really run your application in clear text either. Really behind the firewall in your corporate environment, I still think that you really should be running it over SSL. And then the idealist case is to have all of your backend systems as well. So your database connection, your user directories, any of your other integrations, have all of those things running over SSL as well. That's definitely a lot more optional, in that those systems tend to be in kind of back corners of the network that are harder to get to, that have more fixed routes to get to them. But it's still a good idea if you can do it. Most of the database connectors all support SSL. So it takes a little bit more doing to get it working, but you can get it working, and it's worth the investment. Atlassian has quite a bit of documentation to help walk you through configuring all of these different things. There are a lot of different kind of standard use cases. What we usually tell our clients, and what you probably have already done or what you will do, is you can set up these applications to run a lot of different ways. They can run right out of Tomcat. They can use Apache as a proxy. They can use something else. They can run in Windows, Linux, Solaris, excuse me, whatever you like. So whatever it is that you're already doing in your internal corporate infrastructure, that's how you should set up these Atlassian applications. It's what you're the most familiar with. It's what you're most likely going to be able to set it up the best with. And it's what's going to be the easiest for you and future admins to be able to admin that service if it runs just like all of your other services. So look through the Atlassian documentation. They have great documentation on hardening Tomcat, hardening Apache, setting up on Linux, setting up in Windows, all the different gotchas that are out there. On top of the actual Atlassian documentation that we have listed here, there's also answers.atlassian.com. There's a robust network of experts like us that can help you through any of these things. And there are a host of other resources that are available to you to help get these things set up right and answer any questions that you might have. So that was system security. Hopefully a lot of that was stuff you're already aware of, things that you already have implemented. Now I want to move over into Jira security, and this again will be largely Jira specific. There are some kind of high level concepts that also apply to the other applications. But really, we're going to look at once you have your server completely hardened and bulletproof from every angle, what can you do within Jira to manage who has access to what? So first off, you have different tiers of administrators. So from the administrative side of things, you have different levels that you can isolate people to. So the highest level is a system administrator, and as a sysadmin, you are allowed to do absolutely everything. If you're a sysadmin, make sure you have a good password, because you can do everything, including blow away your entire Jira instance. You could take an old backup and overwrite it. You need a little bit more. You need actual physical access to the server to figure out what file and all of that too. But you can do everything. You can set up the SMTP servers and mail servers, all the integrations that actually touch the server disk or low-level IT systems in your infrastructure. That's what the system administrator can do. The Jira administrator can do just about everything, but it can't do any of those kind of file system or low-level system integrations. So importing, exporting, SMTP configuration, things that actually touch the server, the Jira administrator cannot do. But the Jira and system administrator are able to create workflows, custom fields, screens, configure projects, field configurations, all of the admin stuff that you do in Jira to configure projects, including permission schemes and issue security levels and all that kind of stuff too. It's worth noting that right out of the box, when you first get Jira stood up, there are three groups: Jira users, Jira developers, and Jira administrators. The Jira administrators group is in both the system administrator and Jira administrator role. So by default, when you install Jira, system administrator and Jira administrator are tied together. So if you actually want to separate it out and have two different tiers of administrators, you need to create an additional group like system administrators, and then change your global permissions, so that the system administrator privilege and Jira administrator privilege are granted to different groups. And then finally, in your permission schemes, you have a ability to administer project permission, the project administrator level. As a project administrator, you have a lot less capability, but you're able to administer your own projects. And really the biggest thing that you can do there is provision users, so you can add users to roles, which allows you to grant people access to your projects. You can also modify components and versions and do a few other things, change the project details. So now we're going to move into more kind of configuring the project and setting the project up to do what you want it to do. Within the permission scheme, there are a lot of different permissions. You have a lot of control over who is allowed to do what within your project. So at this point, they're already an authenticated user that's logged into Jira. Now the permission schemes are driving what they're allowed to see, what they're allowed to do. So underneath the project permissions in the top right corner there, so the ability to administer projects, that makes you a project administrator. The browse project permission gives people read-only access to the project. So you can have read-only participants or you can have interactive participants. Underneath the issue permissions, there are quite a few different actions here that you can control whether or not people can do it. So the creating and editing issues are two totally different things. So you may have users are able to create issues, but only developers or service desk operators are allowed to go back and edit issues or schedule them to set the due date. A lot of these things we usually grant to users because they're very useful. The ability to assign a ticket, to link issues together, and so on. There are a couple that are kind of Atlassian workflow specific, and that's the resolve issue and close issue. If you create your own workflows, you don't necessarily have to integrate those two permissions into it. And then underneath comments, this actually relates to comments, work logs, and attachments. They're just basically the exact same architecture, so I only wanted to cover one of them. But it really comes down to, are you allowed to add them? Can you edit your own? Can you delete your own? Can you edit all of them, or can you delete all of them? So you have a very, very granular permission structure here to control which different groups of people are allowed to do things. So if you use role-based permission schemes where you assign roles to each of these things, users are allowed to create issues, developers are allowed to edit issues, administrators are allowed to administer the projects. And you assign this permission scheme to a project. And then within that project, you go into the roles and you assign groups to those different roles or assign users to those roles. Now you have a reusable permission scheme we can have different groups of people that play the same role in different projects doing different things. We use that also in workflows, which we'll look at next. And that just makes everything reusable, so we can have one standard set of schema. You know, we have the Praecipio permission scheme, the Praecipio way of doing things, or more generically, a agile software development project versus a service desk project. We can have permission schemes for each of those things. And then all we have to do is in the project itself to have, you know, service desk A and service desk B. In order to provision the correct people to it, we just have to add them to the correct roles. And from there, the permission scheme will drive everything else. Using roles is especially important if you add workflow conditions, which is a really nice way of being able to add additional control into your workflows. So, excuse me, conditions allow us to show and hide workflow buttons from different users based on their permission. So a very common way to do this is that the users in the project role, say we have a development lifecycle where anybody can suggest a new feature or report a bug, but then that needs to be qualified before it actually gets approved for development. Well, we'll have some sort of a change advisory board or qualification group that takes all of all of these new requests and then validates them before they can get into the development backlog. So by using a condition here, we can have one workflow where new tickets get created, then they get validated, then they get approved for development. And that approved for development transition, we can put a condition on it that says you have to be in the project role of change advisory board or whatever our group is called that does the actual approval for development. That ensures that everything that is in the new request queue stays there until it goes through our approved process to get approved for development. And that way people can't just push their own features into development just because they want them. Finally, we have issue security, which gives us within the project itself, it gives us the ability to show and hide issues from people. So our permission scheme grants people access to the project. But once you have access to the project, you can see absolutely everything in it. Issue security schemes allow us to take that a step further, where you'll only see some of the issues in a project, but not all of them. A standard use case for this is a external client-facing service desk. This is actually just what Atlassian does. So if you file a support request with them and you log into your instance of Jira, you'll see that one ticket. Now they have tens of thousands, hundreds of thousands of tickets, who knows how many they have in their instance, but you only see yours because your security level only allows you to see your tickets. So in this scenario, we have client A and client B, and we don't want them to know about each other, but we want them both to be able to report tickets to us. So we have three different security levels. We have our lowest one, our private one, and that's our default, so that if nobody picks a security level, it'll automatically get set to private, and that way we don't accidentally expose any information to any clients. That just has our service desk operators in it. And then client B has our service desk operators as well as all of our client B group. So everybody that comes in from client B belongs to that client B group, and then they will get their security level applied to them. So if they come in and they try to create a ticket, it'll automatically set it to the client B security level because that's all they have permission to. So service desk operators will see everything. Each of our clients will only see their specific issues. And here we see running the exact same JQL. The result set that comes back is different. So client B only sees client B's password problem. Client A sees client A's password problem. This is one thing that Jira does a really, really good job of. As long as you get your permissions set up correctly and people have access to the things you want them to have access to, Jira does a really effective job of hiding everything else from them. So obviously there's at least 2 issues in this project, but it's only telling you there's one of 1 issue. So it never leaks any information in terms of how many other issues are out there. In all of the gadgets that are reported on your dashboards, all of the project reports themselves, filter results, all those things, before it does any sort of calculations or number crunching, it gets back the result set that's relevant just to that specific user. So users can run the exact same filters and get back totally different result sets based on their security permissions. And then I just want to kind of reiterate, everything we talked about today was kind of security focused, but really using your permission schemes effectively, using issue security effectively does more than just keep people out of where they're not supposed to be. It also hides information from them that they don't care about. It's very common for companies to have 60, 70, 100 projects. And as an individual developer, I might only be working on 2 or 3 of those projects. If I have to look at all of that other stuff, it just adds a lot of noise to the system. So by effectively using the permission schemes to hide all that other stuff from me, I don't have to care about it. I don't have to wade through it to get to the stuff that I care about. So I guess just in conclusion there, remember that your security, it keeps you safe, it protects you, but it also helps you keep your data organized. So I hope you enjoyed that. Please let me know if you have any questions.
Yeah, Chris, I've got a couple questions. I've got one from Ken. Okay, so Ken's asking the following question. We terminate SSL and Apache for both Jira and Bamboo, but have a heck of a time getting Jira and Bamboo to recognize each other, like importing Bamboo gadgets into Jira or having Bamboo fetch issue details from Jira. Any recommendations on configuration best practices?
Yeah, so we've kind of tried all the different ones throughout the years, and application links has come a long way. It has always been a little bit of a headache because it's definitely another one of those kind of black boxes where it doesn't work and you keep poking at it and eventually it seems to work. One of the ways that Atlassian said that they did it was they have, Apache terminating both the applications, but then they had Jira and Bamboo talking to each other. I think they were both on the same server in this particular instance, but had them talking to each other directly. So they weren't going through Apache, they were just directly talking to each other. We had tried that, we set it up, I kind of had it working a little bit for a while, but it ended up causing more problems than it solved. What we do now is we just import the SSL certificate into the key store for both Jira and for Bamboo. So Jira comes bundled with its own. Bamboo uses the system key store. So we just put the SSL certificate in there, and we make our application links directly over SSL through the same public interface that people actually access it from. That's really what's been working the best. The problem that I have now, actually, just since we upgraded to Jira 6, is that Bamboo will go into Jira and pull information out of it, but Jira will not go into Bamboo. So any ticket that has a build associated with it, when I go to the Bamboo tab, I don't see anything. And I haven't been able to figure out how to get around that. But we're running both the latest version of Jira and the latest version of Bamboo. So I hope that helps. But I would say so Apache and all the key stores all have to trust the same certificates, and that's the biggest hang-up that we've had.
Okay, great. Thanks, Chris. And let's see, next question from Hal. Any advice on password policy enforcement? So let's say we've got some minimum requirement on password characters and resets or changes.
Sure. So the Atlassian tools directly don't enforce any policy management. So really the way to implement that is to use whatever your directory server is. So Fedora directory server, OpenLDAP, Active Directory. Active Directory seems to be the most common one in enterprise. But you're going to enforce your password policy there, so you can set your complexity, history, length, how often it needs to be changed and all that. And then just point Jira and your other applications at Active Directory. And that will enforce all of your password policies. Now, with those connections, depending on where Jira sits in your enterprise and kind of how big your enterprise is, there's a couple different ways you can set it up. So if you do one of the read-only options, then users need a way of setting their password outside of Jira, so either on a Windows workstation or through some other tool. If you use the read-write connector, any changes that you make in Jira will then be reflected in Active Directory as well. So again, that's usually not what most large enterprises want to do, but we do have a few clients that do that, and it's an effective way for people to be able to manage their password and email address and display name and stuff like that. And then it will update Active Directory, which will update all of their other systems as well.
Okay, great. Thanks, Chris. Last question I've got here right now from Heath. Can you talk about a little more about Tomcat hardening?
Sure. So for Apache and Tomcat hardening, really the real answer is that Atlassian already has documentation on it, and it's best to go look at their documentation. But as a general statement, Tomcat is already pre-configured when you install any of the applications that use. I think Bamboo actually uses Jetty, but in that case, all of those application servers are already pre-configured by Atlassian to follow the best practices. So if you have more kind of intense hardening needs, you have access to all the Tomcat files. It's a little bit more cumbersome, I think, in Windows, but I'm a Linux guy, so that's probably why I think it's more cumbersome. But in either case, in Windows or in Linux, you have the ability to go in and change any of the configuration settings that you want for either Tomcat or Catalina. But out of the box, it's already going to be hardened. And then Apache is not really ever bundled with any of these, so if you're going to use Apache as a proxy, then you can just follow the standard best practices for hardening Apache as well. And there's a handful of them. If you want to get really anal about things, you can remove the version number, but otherwise there's this kind of the standard Apache hardening things. And then actually, this doesn't relate to either of those, but as far as SSH goes, it's also a good idea not to allow root to SSH into the server, and just kind of other basic system hardening things like that. And then the last note that I'll say, this is a highly contested and debated thing, I think, in the sysadmin world, but in general, I think a lot of people would say that Tomcat is an application server. It's not a web server, so it's really best to put something like Apache in front of it, and that will do a better job of handling malformed requests and other garbage that might get thrown at it, either intentionally, maliciously, or just accidentally by poorly formed requests.
Okay, so just a reminder, the next webinar planned is Jira Workflows Primer, August 7th, 11 a.m. Central. We'll hope you'll join us for that and share the information with your colleagues and other folks that you know. Otherwise, thanks very much. We appreciate your time on the call. We'll submit out a recording so that you can view it or share that as well with your other colleagues. And also contact us at contact@praecipio.com. We'd love to help you out on your next project. Take care and thanks so much. Bye-bye.